Welcome to lecture 1 of week 3 of the SWM course. In week 3, I will be covering two aspects. First is functional aspect, elements of sustainable waste management, and second is material flow in society and circular economy associated with solid waste management. So, in the lecture 1, I will be covering functional aspect of solid waste management. These are the contents which are taken under this lecture. First is effective management of solid waste. Effective solid waste management are needed to ensure better human health and safety. They must be safe for workers and safeguard public health by preventing the spread of diseases. In addition to these prerequisites, an effective system of solid waste management must be both economically sound and sustainable. Environmentally sustainable means it must reduce as much as possible the environmental impact of waste management, and economically sound means it must operate at a cost acceptable to the community. Clearly, it is difficult to minimize the two variables, cost and environmental impact, simultaneously. There will always be a trade-off. The balance that needs to be struck is to reduce the overall environmental impact of the waste management system as far as possible with the acceptable level of cost. An economically and environmentally sustainable solid waste management system is effective if it follows an integrated approach, that is, it deals with all type of solid waste material and all sources of solid waste. The figure given in slide shows the framework of an integrated waste management system, where integrated waste management system has some input such as waste. It requires energy as well as other material. The output is organic waste, plastic, paper. Integrated waste management follows the organic waste, plastic waste, paper, metal, glass, as well as the non-recyclable materials. The output is compost, secondary products and useful energy. And the output waste is air emission, water discharge and inert landfill waste. An effective waste management system includes one or more of the following options: waste collection and transportation, resource recovery through sorting and recycling, through separation, resource recovery through waste processing, that is recovery of material or recovery of energy through biological, thermal or processes, waste transformation, reduction of volume, toxicity or other physicochemical properties of waste to make it suitable for final disposal, and the last is disposal on land. The waste management system which are self-reliant and self-capable can sustain for far. This figure shows a representation of expected financial flow in a sustainable waste management system, where the output such as secondary products, compost and useful energy are generated, which result in revenue generation, and the input are fixed cost, operating cost or transportation cost. There is initial investment is also involved as the input cost, and sometimes the citizens pay for these collection or management of this waste. So, there should be a cycle so that whatever the waste management system is followed should sustain for long duration. Now, the functional element of solid waste management. The solid waste management involves multiple interdependent steps that aim to handle, process and dispose of waste in an environmentally sound and economically viable manner. These functional elements are as follows. First is waste generation, second on-site handling and storage and processing, third is collection, fourth transfer and transport, processing and recovery, thereby disposal, and also the monitoring and control of the whole process is important. This shows the flow diagram of typically solid waste management system function element wise. So, there is the generation, it may be either stored or sent to resource and recovery and recycling. Stored item is further collected to a secondary collection point, and from there it is either using by transport to disposal point, or then after resource and recovery and recycling is done. Then after there is a processing and incinerator or composting process, and whatever leftover is finally disposed of. So, there is an integration approach. The functional element of solid waste management is picturized in table. The activity associated with management of solid waste from the point of generation to final disposal have been grouped into the 6 functional elements shown in this figure. First is waste generation. Waste are generated at the start of any process and thereafter at every stage as raw material are converted into goods for consumption. The source of waste generation determines the quality, composition and waste characteristics. For example, waste are generated from household, commercial outlets, industries, institutions, street sweeping or cleaning and other municipal services. The most aspect of this part is the solid waste management system is the identification of the waste. Next is the waste storage. Storage is a key functional element because collection of waste never takes place at the source or at the time of their generation. The heterogeneous nature of waste generated in the residential area must be removed within 8 days due to shortage of storage space and presence of biodegradable material in the waste. On-site storage is the primary importance due to aesthetic considerations, public health and economics involved in it. Some of the options for storage are plastic containers, conventional dustbins, use the wall drums, large storage bins, etc. These are the picture of different type of container. There are two types of collection generally. First is primary collection and second is secondary collection. Primary collection includes the gathering of solid waste and recyclable material from the source of generation houses, offices, apartments, shopping center, etc. Primary collection of solid waste include collection of solid waste from house to house, either by door-to-door collection and disposed kept in the ward or corners. The secondary collection is the collection of solid waste from primary collection locations to processing facility or disposal site. In secondary collection, curbsites container solid waste is transported using larger size container to disposal facility or further treatment. Waste collection. This includes gathering of waste and hauling them to the location where the collection vehicle is emptied, which may be a transfer station or a processing plant or the disposal site. Collection depends on number of containers, frequency of collection, type of collection services and routes. Next is transfer and transport. This functional element involves the transfer of waste from a smaller collection vehicle where necessary to overcome the problem of narrow access lanes to larger one at transfer stations. The subsequent transport of waste, usually over long distances, to disposal sites. The factors that contribute to the designing of transfer station include the type of transfer operations, capacity, equipment, accessories and environmental requirement. Next is processing. Processing is required to alter the physicochemical characteristic of waste for energy and resource recovery and recycling also. The important processing technique include compaction, thermal volume reduction, manual separation of waste component, incineration and composting. The next one is resource recovery and recycling. This includes various techniques, equipment and facility used to improve both the efficiency of disposal system and recovery of usable material and energy. Recovery involves the separation of valuable resource from the mixed solid waste delivered at the transfer station or processing plants. It also involves size reduction and density separation by air classifier, magnetic devices for iron and screen for glass. The selection of any recovery process is a function of economies, cost of separation versus the recovered material product. Certain recovered material like glass, plastic, paper, etc. can be recycled as they have their own economic value. Next is waste disposal. Disposal is the ultimate fate of all solid waste, be they residential, semi-solid from the municipal and industrial treatment plants, incinerator residues, compost or other substances that have no further use to the society. Thus, land use planning become a primary determinant in the selection, design and operation of landfill operation. A modern sanitary landfill is a method of disposing solid waste without creating nuisance and hazards to public health. Generally, engineering principles are followed to continue the waste to the smallest possible area, reduce them to the lowest particles volume by compaction at the site and cover them after each day operation to reduce exposure to the vermin. One of the most important functional elements of solid waste management therefore relates to the final use of reclaimed land. This figure shows the circular economy infograph sustainable business model. a scheme of product life cycle for raw material to design, production, consumption and reusing. Now, environmentally sound solid waste management. The fundamental principle of environmentally sound sustainable waste management, which take into account economic and social issues along with environmental impact consideration, include the following: to ensure sustainable development of the ecosystem and the human environment, to minimize the impact of human activity on the environment, to minimize the impact on the environment and maximize the ecosystem carrying capacities, to ensure the implementation of environmentally sound solid waste management through environmentally sound technologies. The environmentally sound technologies refers to the cost-effective and energy-efficient technologies which generally perform better on the environment as they do not pollute the environments via components such as air, land or water, and consider the reuse, recycling or recovery of the waste. EST can be characterized broadly on two categories: hard EST and soft EST. Soft EST includes equipment, machine and other infrastructure with their material accessories to handle waste products and monitor or measure the quality of air, water and soil. The software EST, this supports and complement hard technologies and include nature-based technologies and management tools. Nature-based technology includes processing and mechanism nature uses within a specific ecosystem and its carrying capacity, while management tools include system and procedure, policy and regulatory frameworks, and environmental performance standard and guidelines. EST is selected based on the following generic criteria, the indicator of which may vary depending on the region in which they are implemented. First is affordability. This means low investment, reasonableness, maintenance free and durability. Second is validity. This refers to effectiveness, easy operation and maintenance. Next is sustainability. This means low impact, energy saving and cultural sustainability. Example of EST for collection and transfer of waste set out container is one of the major factors that most collection system depends on. This is usually a paper or plastic bag or metal or plastic garbage or craft paper bags in a metal or wooden frame. Set out containers of rural areas include bags, pots, plastic or paper bags, cane or reed basket, concrete or brick vats, urns, boxes, clay jars or any kind of container available. Non-compactor trucks are more efficient and cost effective than compactor trucks in small cities in areas where waste tend to be very dense and have little potential for compaction. The use of lighter, more energy efficient box trucks, vans and dump trucks can be appropriate for sparsely populated areas where the main constraint on the collection efficiency is distance. Transfer trailers or compacting vehicles can carry large volume of municipal solid waste than regular collection trucks, which allow them to travel long distances carrying more waste. This lower fuel cost increases labor productivity and save on vehicle wear. Now the factor affecting solid waste management system. Many factors influence the decision-making process in the implementation of solid waste management system. Some of the factors that need to be considered in developing solid waste management system are listed below. First is quantities and characteristics of waste. Quantities of waste generated generally depends on the income level of family, as higher income category tend to generate larger quantity of waste compared to low income category. The quantity ranges from 0.25 to about 2.3 kg per person per day, indicating a strong correlation between waste production and per capita income. One of the measure of waste composition is density, which ranges from 150 kg per meter cube to 600 kg per meter cube. Proportion of paper and packaging material is the waste largely account for differences. When the proportion is high, the density is low and vice versa. The wastage of high density reflects a relatively high proportion of earning matter and moisture and low level of recycling. Next is climate and seasonal variations. There are regions in extreme north and south where temperatures are very low for much part of the year. In cold climate, drifting snow and frozen ground interfere with landfill operations, and therefore trenches must be dug in summer and cover material stockpiled for winter use. Tropical climate, on the other hand, are subject to sharp seasonal variation from wet to dry season, which cause significant changes in the moisture content of solid waste, varying from less than 50% in the dry season to greater than 65% in the wet months. Collection and disposal of waste in the wet months are often problematic due to the humid climate. High temperature and humidity cause solid waste to decompose far more rapidly than do in the cold climate due to the moisture content as well as the microbial activity. The frequency of waste in high temperature and humid climate should therefore be higher than in the cold climate one. In subtropical and or desert climate, there is no significant variation in moisture content of the waste due to low rainfall and low production of leachate from sanitary landfill is expected. High winds and wind-blown sand and dust, however, cause special problem at landfill sites. While temperature inversion can cause airborne pollutant to be trapped near ground level and landfill site can affect groundwater by altering the thermal property of the soil. Physical characteristic of an urban area. In urban areas where the layout of street and houses is such that access by vehicle is possible and door-to-door collection of solid waste is accepted norms either by large compaction vehicle or smaller vehicle. Added to this is the problem of urban sprawl in the outskirts where population is growing at an alarming rate. Access ways are very narrow, unpaved and tortuous and therefore not accessible to collection vehicle. Problem of solid waste storage and collection are most acute in such areas. Next is financial and foreign exchange constraint. Solid waste management accounts for a sizable proportion of budget of municipal corporation. This is allocated for capital resource which go toward the purchase of types of equipments, vehicles and fuels, labor cost as well. Typically 10 to 40% of revenues of municipal cities are allocated to solid waste management. In regions where wage rates are low, the aim is to optimize vehicle productivity. The unfavorable financial situation of some countries hinder the purchase of equipment and vehicles, and this situation is further worsened by the acute shortage of foreign exchange. This means that the balance between the degree of mechanization and size of the labor force become a critical issue in arriving at the most cost-effective solution. And in addition to this, as I discussed in the first week, the political intervention where the urban local bodies is made responsible for the collection and disposal or treatment of the waste and the fund is given by the state government. If the government at urban local bodies is ruled by the same party and the state government, then there is no problem. Otherwise, there is a tussle between the urban local bodies as well as the state government. The example is the earlier government of AAP and the municipal corporation ruled by the Bharatiya Janata Party. The fourth constraint is the cultural constraint. In some regions, long-standing tradition preclude the intrusion of waste collection on the precincts of household and therefore influence the collection system. In others, where the tradition of castes persists, recruit to the labor force for street cleaning and handling of waste must be drawn from certain section of the population, while others will not consent to place storage in their immediate vicinity. If social norms of community more often than not override what many may consider rational solution. Waste management should therefore be sensitive to such local pattern of living and consider these factors in planning, design and operation. Management and technical resource. Solid waste management for being successful requires a wide spectrum of workforce in keeping with the demand of the system. The best system for a region is one which makes full use of indigenous craft and professional skill and or ensure that training programs are in place to provide a self-sustaining supply of trained workforce. This slide shows the urban situation in 9 major cities, where Delhi produced the garbage generated 3,880, whereas garbage clear is 2,420, and annual budget is 1,016 crore. And the Surat is, you can see that the garbage generation ton per day is 1250, thereafter the cleared is 1,000, whereas the annual budget is 170 crore. These are the references used in this presentation. So in the lecture 1, I deal with the integrated solid waste management and the constraint with the solid waste management, and next part I will carry on the same topic and another aspect of waste management. Thank you. Till then.